Welcome to this explainer. Today, we're diving into a massive, frankly overdue evolution in how we run our infrastructure. We're finally moving past the days of basic, rigid automation and looking at how we can add real, adaptive intelligence to our deployments. If you've ever felt like you're constantly putting out fires instead of preventing them, well, you're absolutely in the right place.
Just think about your current DevOps setup for a second. What happens when your infrastructure literally needs to think for itself? Let's be honest, most of us are dealing with intense alert fatigue or just relying on clunky manual scaling rules. Traditional DevOps is basically like a simple thermostat. It only turns the heat on after the room is already freezing. What we're building today is way more like a smart home, a system that learns your habits and preheats the house before you even walk through the front door.
Okay, so let's unpack this massive paradigm shift. Traditional DevOps automates tasks based on fixed, hard-coded rules. It's very binary. If CPU hits 80%, scale up. Boom, done. But AI-driven DevOps, or AIOps, that actually automates the operational decisions themselves. It learns patterns from historical data and dynamically adapts when the environment, as it inevitably does, changes. Here's our quick roadmap for today. We're going to cover why AI for DevOps, the modern AIOps toolkit, building a predictive autoscaler, automating continuous model learning, and finally, how to take this all from the lab to production.
Starting with part 1, why AI for DevOps? It really comes down to 3 converging trends.
Moving to part 2, the modern AIOps toolkit. This is where we bridge machine learning and automation.
The absolute crucial point here is that you don't need a PhD in machine learning to add intelligence to your stack. You just need the right ecosystem of tools. Notice how the tools you probably already use connect seamlessly with ML. Prometheus provides the historical metrics, scikit-learn creates the predictive insights from that data, and then cloud-native solutions like Argo orchestrate the resulting actions. It's like a giant puzzle where the pieces actually fit.
All right, part 3, building a predictive autoscaler. Let's actually give a cluster a brain.
Now, to give our cluster that brain, take a look at the clean separation of concerns in the code structure here. We've got a machine learning predictor right at the top, a scaling script in the middle, and our target Nginx sample app sitting at the bottom. The really cool part? The intelligence is completely decoupled from the application it's managing. It's a game changer for keeping things clean.
To actually make this work, we're relying on the foundational feedback loop of AIOps. Step 1, observe the data. Step 2, learn the patterns. Step 3, predict the future state. And Step 4, act on that prediction. Every single iteration through this loop strengthens the system's understanding of itself. It's gradually replacing those manual, fixed heuristics with purely data-driven behavior. And in action, this flow completely flips traditional scaling on its head. Instead of reacting to CPU spikes after your users are already complaining about latency, our autoscaler proactively queries the Flask API every 2 minutes. It gets a prediction and scales the pods before the spike ever happens. Proactive, not reactive.
To train this predictive model, we generated 24 hours of synthetic CPU load data to mimic a typical daily traffic cycle. By using a random forest regression model, we found out something pretty interesting. The dominant predictive feature was actually just a simple 10-minute rolling average. Because of this, the system learned to predict the CPU load within a stunning 3.75% margin of error. I mean, think about that. It literally knows what your infrastructure will need before it actually needs it.
But, as amazing as that sounds, we do have to address a fatal flaw in what we just built. What happens when the world changes? A model that's trained just once offline, no matter how incredibly accurate it is on day one, is inevitably going to suffer from model drift. As real-world user behaviors evolve, or holidays hit, or you launch new features, that static brain is going to become dangerously out of sync with reality.
Which brings us to part 4, automating continuous model learning. We need to fix that drift.
Right, so to fix model drift, we have to move past relying on a one-off offline script. Instead, we automate a continuous pipeline where fresh telemetry triggers retraining, updating the system entirely on its own. The system trains on fresh data, publishes the new model artifact, rolls it out to the API, and then repeats the whole shebang.
So, how do we actually orchestrate that? Well, we use Argo. By sharing a persistent volume claim between the training pod and the serving pod, we create a common drop-off point for the model. We define workflow templates for retraining and restarting, and then we just schedule an Argo cron workflow to run hourly. It spins up a training pod, updates the model on the shared volume, and restarts the API to load the new brain. Literally zero human intervention required. The cluster is basically teaching itself.
Finally,
Part 5. From Lab to Production. Let's talk about scaling these concepts up.
Now, you might be wondering how a local kind cluster and some synthetic data actually translate to your enterprise day job. Well, the great news is that the tooling scales up perfectly. Your synthetic CSVs, those become live Prometheus or Datadog metrics. That offline Python script becomes a fully governed ML flow or Kubeflow pipeline. The simple cron job autoscaler turns into a robust, event-driven Kubernetes operator, and your local kind cluster becomes a massive EKS or GKE environment. The tooling changes, sure, but the underlying concept of connecting observability pipelines to intelligent scaling loops, that remains exactly the same.
So as you look at your own environments and your own deployment pipelines, I want you to ask yourself, are you still maintaining fragile, manual heuristics? Are you still waiting for things to break before you react? Or are you ready to build a continuous learning loop and finally give your infrastructure the real intelligence it deserves?